video is showing the Lewis dot structure of covalent molecules. Covalent molecules are formed by sharing of electrons, and once the atoms are chemically bonded, they become more stable due to the less energy. So for single bond, 2 electrons are used. For double bond, 4 electrons are used. For triple bond, 6 electrons are used. You can see these 2 dots actually as representing 2 electrons. So when we are joining those 2 dots, actually making this dash line, this is our bond. Okay? So to work on these, we use these basic steps, and this is also on Google Classroom. You look at the type of atoms and look at the valence electrons. You can refer to for the valence electron, either you can write the electron configuration, or you can look at the periodic table. For a group element, the valence electrons are equal to their group number, and then you count them total together. And you're going to distribute those total electrons, the valence electrons, among all those atoms that are making up a molecule. In the middle goes carbon atom, and if carbon atom is not there, then the least electronegative atom goes in the middle. Symmetry is good whenever is possible. Hydrogen and halogens, if you have them, then you put them in the end. And if there is oxygen, that also goes in the end, except for hydroxides and peroxides. 2 electrons you put in between the atoms so that there is a single bond in between the atoms, like 2 atoms. We want to make sure that first there is a single bond. And distribute any remaining electron, whichever electrons are remained, you want to make sure you distribute them in such a way that all those atoms that are making up the molecules, they attains an octet. And then you change the shared pair of electrons to a long dash, the way I was showing you just now, and that long dash is actually representing a bond. If there are not enough electron pairs to give each atom an octet, then you move unbonded pair of electrons to form double or triple bonds. So the examples we are going to work on is going to clarify all the rules we are talking about. So you can take a screenshot if you want, and it is also on Google Classroom. Let's start with hydrogen. That's the simplest one, the first element on a periodic table. It's a hydrogen molecule. So hydrogen has 1 valence electron, right? And since it is 2 atoms, so I'm going to multiply by 2. So now I have total 2 valence electrons. I have to distribute these 2 electrons in between the 2 hydrogen atoms. Here you go. So what happens as a result of distribution of these electrons, this hydrogen is happy now because it has 2 valence electrons. It can pretend to be a helium. After all, they all want to have a complete octet. Here, another hydrogen, this can pretend to be a helium as well because its electron configuration is same as helium now. Now you are going to connect these, and when you join them, you are actually making a bond. 2 dots connected together, 2 electrons, 1 bond. So here you go. This is single bond, and for single bond, we used 2 electrons. Okay, let's go to the next one. Oxygen molecule. Let's see how is oxygen molecule different from hydrogen molecule. Valence electrons for oxygen is 6 and it is 2, so you're going to multiply by 2 since 2 atoms, and we have to distribute now these 12 electrons between the 2 oxygens. So these are my 2 oxygens. We have to distribute. Remember, we talked about we have to have at least 2 electrons in the middle to make a single bond. Now whatever is left over, the 10 electrons, we are going to divide in between them. So here, okay. Now this oxygen, you want to make sure that they are total 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that we are not making any mistake. Now this oxygen here, 1, 2, 3, 4, 5, 6, 7, 8 completes its octet. However, this one doesn't. 1, 2, 3, 4, 5, 6 only. And we have to make sure that they all complete their octet. So what are we going to do? We are going to move these 2 electrons over here. And what happens as a result? As a result, this is what is going to happen. Okay, I'm not making any changes at all. All I did is I brought this pair of electrons in the middle so that both oxygen have a complete octet. This one, 1, 2, 3, 4, 5, 6, 7, 8. Happy, happy. This one, 1, 2, 3, 4, 5, 6, 7, 8. Happy, happy. Now they both are happy. Now when you connect it, and then the leftover electrons right here. These are unbonded electrons, unshared electrons, and this is double bond. You notice the difference between oxygen and hydrogen? Even though you said H2, O2, but their chemistry is very different just because their internal arrangement of electrons is different. Alright, nitrogen. Let's see how is H2, O2 and N2. How is N2 different from them? Nitrogen has 5 valence electrons. Since it is 2 atoms, you multiply by 2, you get total 10 electrons. Now you have to divide these 10 electrons among these 2 atoms. So again, same rule, 2 electrons in the middle to make sure that there is at least a single bond. Okay, and rest of them are divided equally. Now look, none of these nitrogen atoms are having a full octet. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So what are we going to do? We are going to move these electrons here. So these 2 pairs are going to go in the middle. And as a result, what are we going to get? We will have 1, 2. So that one pair, this is another pair, and this pair was already here. When you join these, 1, 2, and then 3, you have triple bond. Okay, so this is the Lewis dot structure for nitrogen molecule. See the difference? We are using 6 electrons. So this is different. It has 3. It has a triple bond. So these were the examples from 7 diatomic molecules that make the shape of 7 on a periodic table. So we did hydrogen, we did oxygen, we did nitrogen. I want you guys to try chlorine, bromine, iodine, and fluorine, and they have a single bond. Now after you guys have tried, if this is what you got, that means you are understanding what's going on. Okay. Alright. I have also written here the nearest noble gas. After all, they are sharing electrons to be just like their nearest noble gas. Okay. So this one is the Lewis dot for chlorine. This is the Lewis dot for bromine. You are going to write here Br. This, let me write it for you. So unbonded electrons you have to show. These are the unbonded. Okay, and in the middle that was bonded. And you're going to do the same thing for this one. You show the single bond in the middle, and then because these electrons are used in a bond, however these are unbonded, so you're going to show them like this. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. But you know that altogether it is 8 electrons. So this is the Lewis dot for fluorine. Let's work on this molecule. Methane, carbon tetrahydride. So carbon has 4 valence electrons and hydrogen has 1. Since it is 4 atoms, you multiply by 4. So total 8 electrons. You're going to distribute these 4 electrons. We are keeping in mind the symmetry. We are following all the rules that hydrogen is terminal. Whenever there is carbon, carbon is in the center. All those rules we have to follow. 8 electrons. Oh, great. These all electrons are used. So there is no lone pair in this case. This is happy with 2. Hydrogen is always happy with 2 because it can pretend like helium. And carbon is happy here. It can pretend to be like neon. So this is the structure, Lewis dot structure for CH4. Okay, there are no lone pairs. Alright guys, let's work on this. Ammonia, nitrogen 5 valence electrons, hydrogen 1, however 3 atoms, so altogether it is 8 electrons. Symmetry. So at least for now, our focus is not the shape or the geometry. Okay, our focus right now is only the Lewis dot structures. When we are going to work later, we are also going to focus on the shapes and the geometry. So how does that happen? Here it is 8 electrons. 1, 2, 3, 4, 5, 6. Okay, I can't put any electrons with hydrogen. Hydrogen atoms are already happy. I'm going to put those atoms here. Now let's see. Okay, 1, 2, 3, 4, 5. Okay, this one, good. This one, good. This one, great. Here. This one, here you go. So they all have their complete octet. Okay. Now, yes, the octet is complete, but are all these electrons used in bonding? No. These, this, these, but not that one. So you're going to write the structure, the Lewis dot structure for ammonia NH3 like this. Show the lone pair. That's your Lewis dot structure for ammonia. Now let's work on one more. How about you guys try? And after you guys tried, this is what you got, then perfect. Okay guys, let's do the other one. Here this one is the Lewis dot diagram. This is the one. Just make sure you always show the bonding pair of electrons, which one are bonded and which one are unshared or unbonded. They're the lone pairs. Carbon dioxide molecule. Carbon has 4 valence electrons and oxygen has 6 valence electrons. However, 2 atoms, so multiply by 2, you get 16 total. And you're going to distribute these 16 electrons among these 3 atoms. Okay. Oxygen. So carbon in the center, that you always start out with the middle first. So first you write carbon, then oxygen on both sides, because we said whenever possible, pay attention to the symmetry. 1, 2, 3, 4. Now I have 12 more electrons left. I'm going to distribute them. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I have total 16 electrons. Now this carbon, if you look carefully, this oxygen's octet is complete. Alright, 1, 2, 3, 4, 5, 6, 7, 8. And so is this one's. However, the octet of carbon is not complete. So our job is to move this pair here, to move this pair of electrons over here. Always move in pairs, guys, because a bond needs a pair. So I did not make any changes except that I moved these pair of electrons in the middle. Now as a result, what happens? Watch carefully. As a result, 1, 2, 3, 4, 5, 6, 7, 8. Octet is complete. Happy. 1, 2, 3, 4, 5, 6, 7, 8. Octet is complete. Smiling. And this one, 1, 2, 3, 4, 5, 6, 7, 8. Octet is complete. Okay, guys? So the octet is complete for carbon. Octet is complete for both oxygens. Now you join these. You're going to make a bond when you join them in the middle here like this. If you can see, here you go, connect them, and okay, so this is the Lewis dot structure for carbon dioxide molecule. This one. Now let's work on one more example of double bond. Ethylene, 4 valence electrons, since it is 2, 1 valence electron, however it is 4 atoms, so total 12 electrons. Carbon, carbon, hydrogen, 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 hydrogen. So 12 electrons, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I can put other 2 here or here, it doesn't matter. So if you look here, these hydrogens are happy. However, this carbon 1, 2, 3, 4, 5, 6, 7, 8 is good. But look at this carbon 1, 2, 3, 4, 5, only 5, 6, only 6. So that's the octet is not complete. So we are going to move this pair over here. And this will become, that pair comes in the middle. Okay, guys, there you go. So this carbon, this hydrogen, this hydrogen, this hydrogen, and this hydrogen, okay, they all are satisfied. Now this carbon 1, 2, 3, 4, 5, 6, 7, 8. So this is satisfied. Now this carbon 1, 2, 3, 4, 5, 6, 7, 8. So this is happy as well. So the octet is now complete. This is right here for all of them. And what do you get here? You get, this is the structure, Lewis dot structure for ethylene. Okay. All right. Now let's work on example with a triple bond. Acetylene C2H2, carbon is 4, but then you have 2, then hydrogen 1, but then you have 2, so total 10 electrons. I'm going to distribute these. Keep in mind the symmetry, 10 electrons, 1, 2, 3, 4, 5, 6. This one I can't add for hydrogen, so I'm going to put them here. And this carbon, their octet is not satisfied, so we are going to move these bonds here in the middle. As a result, I will have 1, 2, 3, 4, 5, 6. So what is happening here? Happy, happy, the octet is complete here, octet is complete here, okay, and the octet is complete for this 1, 2, 3, 4, 5, 6, 7, 8, and then 1, 2, 3, 4, 5, 6, 7, 8. Their octet is complete, and you will have 1, 2, 3. Okay, so that is the structure for covalent compound with a triple bond. Here's a Lewis dot structure. Now, please try these. Pause the video, try these molecules, and if this is what you got, great. If you don't get these, that means you need to go back and watch the video again. Thank you.